This video is to help you with the second side of the flow chart, how to write a formula when you are given a name of a compound. So very similar, but very different. There's similarities and differences here. Sometimes I have information on this side that I don't have on the other side. So you just have to be careful. But just like before, we always start at the top. Okay. And then we're going to work our way through. So the first question we ask ourselves, does the name contain a prefix or the word acid? And right away, by this first question, you will be able to determine the type of compound that it is. Because remember, in order to name it or write it the formula correctly, you have to know the type of compound because you have to know, do you need charges? Do you not need charges? That kind of thing. So if it has a prefix, then that means that it is molecular. So the prefix tells how many. So if it's dioxide, that would be 2 oxygens. There's no crossing, there's no charges involved there. If it has the word acid, then the type of compound is an acid. So it will start with H+, and then you use the table to figure out the rest. If it doesn't have either of those, then the type of compound would be ionic. And so from there, I have some more clarifying questions just to make sure that you know where those charges go. And it's also important to know that both for acids and for ionic compounds, you have to balance the charges to 0. If you don't, then it's not going to be written correctly, possibly. Okay, so I've got 3 examples to try just so that we can see how this all works out. So the first one we're going to try is sulfuric acid. So sulfuric acid, starting at the top. I guess I'll write it down here. I did that last time, didn't I? So sulfuric acid, first question, does the name contain a prefix or the word acid? Well, it does contain the word acid. So that means that the type of compound is acid. So that means that the formula is going to start with H+. We're going to combine the hydrogen with this anion. And the way that we know what hydrogen gets paired with is using our table. Okay, so in the word, we have sulfuric. We do not have hydro in front, and we have ic at the end. So that would be this last row in the table. So if we were to take off the ic, which sulfur is a weird one, but we had to have the whole sulfur and not just sulf. But take off the uric, and that is going to be sulfate. Okay, so that is a polyatomic ion. Look at the polyatomic ion list if you don't remember. And so that would be the SO4 -2. So at this point, we are almost done. Last thing to do after you figure out that it's an acid, we have to balance the charges to write the formula. So I'm going to do it the cross way to make things simpler. If you don't know how to do it this way, do it your regular way of counting. But the number 1 will become the subscript on the SO4, and the 2 will become the subscript on the H. So the formula for sulfuric acid is going to be H2SO4. So it's just going the opposite way of what we did with the last one. Next example that we're going to do is silver nitrate. So for this one, does it contain a prefix or acid? Neither. It does not have acid, and it does not have dis or tris or anything like that. So since it's neither, then the type of compound is going to be ionic. So now we have to just have some clarifying questions to help us write it out correctly. So first question, does it have a polyatomic ion? Remember that an easy way to spot a polyatomic ion is if you have ATE ending, which this one does. So nitrate is going to be on the list of your polyatomic ions, and that is going to be NO3, -1. So we should say yes, it does have a polyatomic ion. Sorry about that. Okay, next question. Does the name contain Roman numerals? No, we do not have any Roman numerals. If it did, that would have told us the charge of the cation, but since we don't, then we're just going to use the charge from the periodic table to figure out that charge on the silver. Now, silver is in the middle. Remember, it's one that does not change its charge, which is why it doesn't have a Roman numeral, but it's one that you're just going to have to remember. Or if you look by the Honkel fiber poster in my room, you'll see that it's Ag silver +1. So silver always has a +1 charge. Okay, and now at this point, we've gotten our cation and our anion. Last thing to do is balance the charges to 0. So in this situation, what's really nice is that we've got a +1 and a -1. So they already balance each other out. We don't have to cross, we don't have to add anything. So the formula for silver nitrate will just be AgNO3. So that would be an example of an ionic compound. Last example we have is dinitrogen monoxide. So first question, do we have prefixes or the word acid? We don't have the word acid, but we do have prefixes because we have di and we have mono. So that means since we have prefixes, the type of compound is molecular. So we don't have to look up charges on the periodic table. All we need to know is that the prefix in front of that element tells you how many there are. It tells you the subscript number. So di stands for 2. So that would be N2 for dinitrogen. And mono stands for 1. So we would have O1, which you don't really have to put the 1 if it's just a 1. So dinitrogen monoxide, the molecular formula for that would be N2O. So use your flowchart, get the hang of it, use it to help you with the other assignment on its learning. And we'll continue to do this every day for the rest of the year. Good luck.